Thank you. Hey, so I'm Julie Lavoie, and I'm going to talk about, as he was mentioning, using machine learning to extract the publication dates of news articles. Can you hear me okay? No? Is that better? Okay, cool. I would just like to start by saying a pro tip, which is don't go get something to eat 40 minutes before your talk in a city that you don't know and get lost, which is what happened to me. So I'm glad I'm here on time. Okay, so I'm going to start. And so I'd like to thank Sawhorse Media, who are clients of mine, for letting me speak about work that I did for them. I'm not used to having a mic like this, so if I wander too far away and you can't hear me, please just let me know. So let's say you want to get the date of one page. That's pretty straightforward, right? You just use scraping. You can use Scrapey or Beautiful Soup or LXML or whatever your tool is of choice. You can kind of look at the DOM and extract the date from there. That's pretty straightforward. And since sites use templates, if you can extract one page from a site, you can typically extract them all. Let's say if we add a second site to this, that's also fairly straightforward. The first site was New York Times. This is Gizmodo. You just add like another case, right? If it's New York Times, do this. If it's Gizmodo, do that. Use the same technique, and you're golden. However, what if we want to extract the date of any page? That's kind of a lot harder. So you can kind of keep on going with the same sort of method for 10, 15 sites, but what if we have 10,000 sites? Are we going to write a program that has 10,000 cases? That's kind of ridiculous, right? Well, what do we do now? Well, we could get people to do it. So we could use something like Mechanical Turk, which has an API. You can send tasks to real humans. It costs about $0.01 per page. I always think this is kind of cool because it's like programming people. It's a little bit kind of vertiginous to me that essentially human cognition has kind of become just one tiny part of a greater computation, not even a really particularly well-valued part at $0.01 per page of a greater computation that's mostly done by machines, right? The problem is, well, this isn't that scalable. So in our case, we process about 1 million pages per week, so that would be 10 grand per week. You know, that kind of adds up. And you can kind of guess at $0.01 per page, well, the quality is not always there. Some foreshadowing is we're going to need this anyways. Okay, so, well, we could get a programmer to do it. So we could look at the data, you see a pattern, you write some kind of like program algorithm that uses heuristics. So you could do something like, let's say if you see in the text it says publish, blah, 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 take the date from there. If you don't see that, look for a div that says publication date or pub date or something like that has a class like that, then take it there, and if not, do something else. Solutions like this can be really good first approximations. However, the problem is sometimes the pattern can be a bit more complex than a human being can understand. The foreshadowing is, well, we're going to need this as part of our overall solution anyways. Or we could get out the big guns. We could get machine learning to do it. Machine learning is cool because it can essentially, quote unquote, see a pattern that's more complex than humans can see. Machine learning is also interesting because it includes both previous solutions. So we're going to do supervised learning, which essentially means we're showing a bunch of examples where we know the answer ahead of time to the model and asking it to sort of extrapolate what to do when we don't know the answer ahead of time, to kind of see a pattern that we can use later. So we're going to need humans to get examples of pages and dates to train the model, right? So we're not really going to escape data entry. And we're going to need heuristics to kind of figure out the features to tell the model to pay attention to as well. So we're not going to escape that part of it either. However, machine learning is a giant pain in the... It's an enormous amount of work, and we should only really use it if the volume of our data or the problem complexity is too much for previous solutions. So I had a friend who wanted to parse dates. I was telling her about what I was working on. She was thinking of hiring an intern to do it, and she said, oh, maybe I'll just use machine learning instead. And so I asked her, well, how much data do you have? And she's like, I have 2,000 results. And I said, do you have 2,000 today and 2,000 tomorrow, or just like flat out 2,000? She's like, just 2,000. And I'm like, just do it by hand. Like, even faster than training an intern. You're going to get an intern, you're going to give them directions, they'll get them wrong, they won't show up on time, you'll have to run after them, you'll have to clean the data because they'll make typos, just literally do it by hand. Or same problem with Mechanical Turk. So you kind of have to use what's appropriate for the amount of data and the complexity of the problem that you have, right? So, okay, so to bring it back to machine learning, well, where to start? I really like this type of problem because you have to kind of start by thinking, how do I, as a human, think of this problem, right? So how do we recognize a publication date? So if we look at this page, how do we know, right? So I guess a bunch of things that we think about is, well, it's probably close to the title. It's probably close to the author. How do we know something's the title? Well, it's usually like a bunch of really big text at the top of the page, right? Like close to the main body. The author, that's a bit more thorny. It looks like a human name, which is a lot harder problem. Near the top of the page, it looks like a date, it has numbers in it. There's month words, days of the week words. It's typically not in the footer. It's typically not in the comments. Or here you have like top stories. Well, we know it's probably not there because there's a bunch of smaller things and they're all grouped together and like they seem less significant, right? So we have essentially 3 different kinds of cues that we can draw on to kind of figure this out. So you have language cues, like it says updated. You have rendering presentation cues, so the kinds of things they would teach to someone in graphic design school. So it's near the top, close to the title, close to the author, where it's positioned, how big is it, that kind of thing. And finally, we have markup cues. So things that are typically not meant to be read by a human, unless you're like a web developer. So things, it's in a div that has a class of publication date. It's in a time tag. But even though normally a human's not going to see these things reading the page, we can still use this, right? So these cues are so strong that even in a language that we don't necessarily understand, this is from a Japanese publication online, we can often actually kind of muddle through and figure out what's the publication date. Of course, if you read Japanese or you read Chinese characters, maybe this is like a bit more obvious to you than the rest of us. But let's pretend none of us know and take a wild guess, right? You can kind of see at the top, you know, if you read one website, that's probably the menu. To the side is probably related stories. The big, you know, there's a picture and then there's the main body of the text that's like the Prime Minister of Japan. And you can kind of see there's a social sharing bar, even though like the names are in Japanese, you can see Twitter, Facebook, all that stuff. And on top, you can see that's probably the title. And under that, you see it's like 2016 and then some stuff and some more numbers. And let's take a wild guess. That's probably when this article was published, right? At least if I was betting my own money, this is what I would say. Let's make it even harder. So here's a page from a Thai newspaper. And it's the same thing. How do we figure out what's the publication date of this article? I don't even vaguely know what this article is about. Like I was looking at what is this picture even? But you can kind of see like there's an advertisement, there's a video of something, there's the title. And Thai is even harder because it actually uses the Buddhist year. So it's not 2016 in Thailand, it's like 2500 something. And so we can also guess, however, because we see the time. We see 0922 and then 2559. I'm going to guess that's the Buddhist year, and that's probably the publication date for this publication. So there's a lot we can draw on, even if like the language and the character set, we might not even know what's going on. So, okay, so now we've kind of thought a little bit about the problem in general terms. Let's bring it back to machine learning. The hardest part for me, what I found, of machine learning is kind of setting up the problem in a way that machine learning can answer. It's sort of like they say about jokes, right? It's like, hey, you set them up and I knock them down. It's like you have to set up the problem in a way that machine learning can answer. So this was actually the first machine, like I had been a web developer for several years and I'd worked on data projects, but this was the first project where I really started to use machine learning in production. And I was very much helped by the CTO I was working with at the time when we're kind of like discussing how we're gonna approach this, found this research paper online, and that's what I ended up implementing. So if you're interested in this topic in more depth, like there's a lot more information in this paper. So there's basically, if you've done machine learning at all, this will be very familiar to you. There's 2 phases. There's like training the model and then using the model in production. And I'm going to talk about, it's kind of hard to kind of give an overview of the steps, so I'm going to briefly go into it, and I'm going over all of them in more detail. So if these next 2 slides don't make that much sense, don't worry, like it's going to become more clear. So in training, this is how we break down the problem. So we get some data. The data looks like a bunch of HTML pages and the publication date that we know. Like we get a human to say, this is when this was published, and we just get a big list of that stuff. For each of these pages, we're going to split it into chunks. A chunk is essentially a DOM element that contains something that's a date. That could be the publication date or it could just be some random crap from the comments. We don't know yet. And then for each of these DOM elements, we're going to do feature selection. We're going to calculate features on each of these chunks, and then we're going to use this, and we're feeding this into the model to train it. In production, there's a few more extra steps. So we go through all this. Now we don't have a bunch of pages. We just have one page where we want to know the publication date. We do the first few things the same. We take that page, split into chunks, calculate features on the chunks, and then pass this feature vector to the train classifier, get a label. The label is going to be, is this the publication date or is this not? And then we have a few more steps. So let's say for a page, you get 3 chunks, you pass them to the classifier says 2 of these have the publication date. How do we decide, right? Which one is actually the real date? So how do we disambiguate that? That's one step. Then, as you recall, the chunk is like a bunch of markup, maybe some text, and a date. I'll show examples, it'll be a bit more clear. So you gotta extract the date from the string from that thing, and then fine-tuning of the whole solution. So step 1, okay, so let's go through these in more detail, which will make more sense. You gotta start by getting data. It's pretty hard to end up with a good solution at the end if you start with crap data. I've always really loved this quote by Charles Babbage, one of the fathers of computer science, which kind of shows that getting good data has been a problem for a long time. So people are asking him, if you put in wrong data into the machine, can you get the right answer? And he's like, I guess the 1864 equivalent of like WTF, he's like, I'm not able rightly to apprehend the kind of confusion of ideas that could provoke such a question. So even back then, it was very important to get good data, and Charles Babbage knew this. So let's start. Data for this project looked like, we basically got like a massive CSV with URLs and got some people on Odas to look at the page and enter the date in the CSV. It looked exactly like this. It's a URL, it's a publication date, look at it, write the publication date, that's it. I download all the pages to use as training data. One thing I found is people are often wrong, and so what I did is I got 3 people to fill in the same CSV, and I only take the result if all of them agree. That eliminated a lot of error. So this being my first machine learning project, I became quickly acquainted with the fact that, sorry?
So to deal with international solution problems, do you have an international crowd to enter the CSVs because you showed us the Thai, the Japanese sites? It was harder to understand what the difference is. Or do you just focus on English?
We focus on English, and but I can answer more questions at the end too. Yeah. But that's a very good question. We focused on English, but yeah, let's talk about that a bit more at the end. So I quickly became very acquainted with the fact that it's really hard to get a whole bunch of data. It's just like a ginormous pain in the... and here are examples of problems that I discovered. So for example, someone would enter the correct publication date into the CSV, and then like a week later, when I'm like downloading this stuff and parsing it, the web page is gone 404. One problem that was actually really hard to figure out was some articles have publication dates when you view them in the browser, so when someone's doing the data entry, but when I go and download it with requests, I don't get any data because the site uses React or another JavaScript framework where you have to render the page to get access to the data, so you just get like an empty page or just like a bunch of JavaScript with no content inside. And that was really hard to figure out like why it wasn't working. Just general like CSV and UTF-8 error. UTF-8 is literally the bane of my existence. And just like data entry problems, so I would tell people if the page is 404, enter like n/a. I decided that was the thing that I said, just drop that result. And of course people enter NA, _NA, like they just, like how many ways can you literally not enter the thing that I told you to enter? It's just crazy. Of course, then I can say, fine, I'll just look for all the misspellings, but then I have to go and look for all those stupid misspellings, so I still have to read through the whole thing. It's just like, I don't know. I started feeling like when you're like a kindergarten teacher and you're trying to tell people like color inside the line and they're coloring, like, what is even going on? And just flat out, so people enter incorrect results just because they make a mistake, obviously, and sometimes they just don't even care. Okay, but let's assume now all our data is great in some magical world. So now we want to split it into chunks. So a chunk being a DOM element that contains a date. So here's, hopefully to help you visualize it a little bit, here are examples of chunks. So it's like some markup, a date, maybe some text. Sometimes there's no text, sometimes it's like a meta tag, stuff like that, but here are examples. And so this is fairly easy for dates because dates have a limited number of formats that they really come in. I've used the same approach for extracting authors, and that's much more difficult because there's no regular expression for what's a human name. That's a much harder problem. So I used a combination of regular expressions and LXML. Basically what I did is I took the HTML page, I slurped it into a big like LXML tree, and I just literally just iterate over every single thing in the tree and say, does this look like a date? Yes, I take it. Does this look like a date? Nope. Just like ignore it and move on. We need the chunk, not just the date, for the reasons kind of I was talking about before, that there's a lot of information in the markup that is like useful for us. So that's why we don't just take the date, we take like the actual markup that includes the date. I'm just going to drink some water. So feature selection is the next step. This is actually why sometimes it's a good idea for this type of problem to not just jump straight into machine learning, but maybe to build a heuristic solution. And I've read stories from a lot of startups where like that's often how they start with their kind of like data science type products. And one good reason is because a lot of features can come from the ideas that you came up with using heuristics in the beginning. In my case, obviously, I was very much helped by the fact that this paper just like listed all the features that they used, and that's what I implemented most of them, and I added a few kind of that I thought of myself. So examples of features were stuff like contain the word posted, modified, published. As you can guess, that correlates fairly highly with having the publication date. Stuff like the header level, like is it an H1, an H2, an H3 tag? Is it a link? Is it bold or not? Stuff like the pixel distance from the top of the page, the pixel distance from the title, like those are examples of features.
So real quick before you go into step two, step three, your step two is to reduce the regex to find a data pattern. Now what do you do if you find multiple hits on that? For example, like your body content had a date in it and header had a date. How are you feeding both as directly into the
Yeah, I take literally everything that looks like a date, and I'm gonna do the selection of what is a publication date like afterwards. So at that stage, I could have the same date like a few times, and I have more than one date at that point. I'm just literally like, these are candidates that could be the publication date, and I'm gonna do feature selection and machine learning on like all of these things and eliminate a bunch of them.
what other data are you taking and feeding into subsequent steps besides just that the string that contains the suspect date?
That's it. I'm just like taking this. I'm taking the date. Sorry, I'm taking these chunks. This is the input into, and I'm calculating features on them, and then this is the input into the classifier. Obviously, I'm also taking the label in the sense of this is data that I know ahead of time, like this does have the publication date or not.
Hierarchy and that sort of location-based information as well?
Sorry?
Are you also tracking the point of the hierarchy and the DOM and all that stuff too?
No. Okay, so feature selection. So at this point, so now I have these like, basically, where am I? Sorry, I just got a bit lost. So now I have like essentially these feature vectors of like all this information that I've calculated on these chunks. And now I'm gonna train the model. This is kind of phrased in terms of a classification problem at the chunk level, at the level of this DOM element. Essentially label this, there's two labels, does this contain the publication date or not? So like yes or no, essentially. I used NLTK and naive Bayes. You could use scikit-learn, whatever your favorite like Python machine learning library is. I'm sure there's a lot of people in this room that can tell me way better stuff I could have used. I basically picked this, frankly, because it was the easiest one to understand. What I did is I read the NLTK tutorial, and to me it was understandable, and then I looked at the scikit-learn tutorial, and I'm like, I have no idea what's even going on here. So I was like, all right, NLTK it is. So this is how I felt doing this tutorial. I don't know if you found the same thing, but for me, whenever I've tried to learn a new technological thing, like at some long time ago, I decided I was going to learn Rails, and you do this little like, let's make a blog tutorial, and you're like, wow, I can do Rails, and I'm so smart now. And then it was the same thing with machine learning. I'm like, oh, I can machine learning all the things, and this is so great, and I felt really awesome. And then this is like any real production problem once you're done the tutorial. This problem was totally like this. Like I loved it and I found it really interesting to work on, but there's definitely just a lot of nitty-gritty that was hard to figure out. And this is like a super cheesy graphic, but I just wanted to use it. So now the model is trained and we can use it in production. So there's a few more steps with respect to now using it in production. So kind of to answer that, hopefully this answers your question a little bit in the back. Let's say for a given page, right, you split it into chunks, you calculate the features, you pass it to the classifier, and the classifier says, like, let's say there's 3 chunks, and 2 of them come out as this has the publication date. How do we decide which one to take? Because this is actually a much easier problem for the question of dates, because an article typically only has 1 publication date. If you're trying to get things like the author, it happens all the time. The articles have multiple authors, so it's not just like there can be only 1 and you pick 1. It's like you have to figure out which one, there could be multiple ones. So this is a much simpler problem than finding an author. So I essentially really just tried a whole bunch of stuff and then tested it to see which one had had the best accuracy. I tried basically picking the first chunk that got labeled as true, like as having the publication date. I tried picking the last one. I tried picking the one that like occurred the most often in the page, like I counted how many times it has occurred versus the other candidates. I tried picking the one that occurs the most often in the list of true chunks, like if you had a whole bunch of chunks that were labeled as a publication date. It turns out what worked out the best is literally just picking the first one. Just because my best guess is it just correlates with being at the top of the page, which is usually where the publication data is. So that just kind of worked out as the best thing. And then, as you recall, the chunk is like a bunch of markup, the date, some text. We want to ditch. Now that we don't need the markup in the text anymore, we want to get rid of it and just return the date, right? So we just use a regex to kind of extract that out of the chunk. And then fine tuning. So this is like a bunch of pre-filtering, post-filtering, and just flat out hacks. So pre-filtering, at the stage where you're turning things into LXML tree, I just flat out just ditch anything that just never really has the publication date. So anything that looks like a comment, anything in the footer, anything that's like related stories, top stories, popular stories, I'm like, okay, get rid of it all. Get rid of images, videos, and JavaScript. So JavaScript has a lot of false positives because if you have a link to the library hosted somewhere else, it often has a date in the URL, and that was like a ton of false positives from there. Also, because that's typically at the top of the page in the header. So I just like get rid of that as well. For post filtering, I remove just results that are obviously wrong. So basically dates that are in the future, pretty obviously that can't be the date. And then I also remove dates that are in the past, but there was actually kind of a gotcha with this where I said, okay, if something is before, let's say 1980 or close to the beginnings of the web, can't really be the date of something on a website. So I'll just eliminate that. However, there are sites like the New York Times where they've started to put historical articles online. So you do have legit articles where they digitized it, but it was published in like 1863, and it's like on the New York Times website. So now you can't eliminate that. Like you have to actually leave those in. So now what I do is I reject things before the 1500s, thinking I'm safe, but preparing this talk, it occurred to me I should really, if I wanted to be like super hardcore, go to like the date of the printing press when it was invented and just like make that my cutoff point so there's like no errors. And the last thing was basically just flat out a hack. This I only thought about at the end, like after iterating over this several times and like looking what kind of errors came out. And this was like, I'm super proud of this hack. This was literally like a 10% increase in accuracy just from this, which is if there's a date in the URL, which happens a lot for sites that use like a CMS. So here's an example, this is cool. It was like some sort of thing about heavy metal and natural language processing that I was reading, and I can guarantee you that it was probably published on April 20th, 2016. So if you see a date in the URL for an article, literally ignore everything I just said and just take it out of the URL, and that is almost always the publication date. The only time this is wrong is if, like, let's say it's published on April 20th and then they make a modification the next day. The CMS sets it so the URL stays fixed, but the actual publication date will be like April 21st. That's the only time I've seen it be wrong. So that was like a massive thing to discover that I didn't think about before I started. Results. So this program has 88% precision on articles sampled from 550,000 publications, which is how many publications we parse in production. The paper itself had around 96% precision. I kind of like very loosely averaged it because they measured it over like different research data sets. I didn't use their data set because I wasn't trying to match their result for the sake of research. I was just trying to parse the stuff that I had to parse, but I just kind of used the result of the paper as a kind of upper bound on what I could hope to achieve. There are several reasons I can think of why these results might be different. The first one would be, I think I'm pretty smart. Hopefully that's true, but I'm not 5 people with a PhD in machine learning. So that was probably responsible for that small difference, or that difference. The other one is that I use a fairly naive algorithm, and they use like something more complicated. I'm not remembering what right now. You can look it up in the paper, or I can look it up later if you care. And as well, there's a few features that they implemented that I had to leave out for reasons I'll talk about right now. So I'm just going to get some water. So I also came across things that basically highlighted sort of the difference between doing something in production and doing something for research purposes. The major one was that features that had to do with a headless browser, so stuff like calculating the pixel distance between the title and the publication date, or the publication date and the author, for us ended up being too slow to do in production. Basically, we parse about 300,000 pages per day, versus like for research purpose, you just leave it chugging along in the lab until it's done and you have your result. So we ended up leaving those out, and you can kind of guess that how close it is to the title probably correlates very strongly, so that's probably part of the difference in accuracy. As well, one difference for us was that for us, it's much worse to return the wrong answer than to return no answer. So in the post-filtering, I kind of like skewed it in favor of like, if I don't feel completely sure, just like reject this whole thing. Like just return nothing versus taking the chance on returning something wrong. Versus research, I think you would just care about like the kind of true results so you can compare how well you're doing. So that was like two major differences. And so I wanted to finish, I guess, with lessons learned. So when I started on this project, I was the only one in my organization that was working with data. I had a really smart CTO to kind of bounce ideas off of, but I also, I didn't have experience with machine learning, and neither did he. And I just had a lot of problems that my web development friends just didn't have. So I had like no one to really talk to about my problems, which is always kind of a sad position in life. And so I watched a lot of PyData talks to try to understand best practices and how did people organize their code and kind of what do they do. So I wanted to list them here as well. So one thing I found super useful that I learned from doing this project was that it's really useful before you go and collect a whole ton of data to kind of go through the whole process and set up like a data pipeline with some tiny set of data. So like say for this problem, to basically take 20 URLs, like do the data entry by hand, just myself, and literally set up the entire data pipeline, write one like super crappy feature and train the classifier, obviously with the result that won't be significant, and just make sure like at every step, everything is in the format that I need it to be before you go and just collect tons of data that turns out to be wrong. That's actually a problem that happened with this, where I had to like do tons of data transformation because I didn't really know. It's only partway through that I really realized how I really needed my data versus knowing from the beginning. So now what I do is I just kind of do a tiny data pipeline at the beginning, and that really helps me a lot. With respect to collecting data in a spreadsheet, if ever you have to do this, if you have like a CSV, I found it like I used to give people directions, and literally everyone just got my directions wrong like all the time. And it also just makes you sound like super picky, but it is picky, right? So now what I do is I just give examples. So if I'm giving people like a huge CSV to fill out, I'll just fill out the first like 10 examples and just like fill it out exactly. If the page is 404, do this. If, the date should be in exactly this format, like just literally give people like how they can't get it wrong. If you're getting people to collect the data online, often it's people where English is not necessarily their first language. So I found that the clearer your instructions, the better. Like don't use slang, don't use idioms, don't like kind of ask them to kind of understand things from context, like just be very precise and like clear. And another thing that was like very, very helpful that also I didn't do for this project and I learned to do it is basically write tools to kind of debug your data pipeline at each stage. If this is something that you know about, for me, like this is kind of how I figured it out myself. If there's some framework or tools to do this like better, I would love if you know about this, like come and talk to me about it, because I'm very interested in learning about this more. But for example, the problem with finding like pages that have no data because of React, that took a long time to figure out, because it's like you're parsing something, you get no answer. Well, where's it going wrong? It's actually going wrong. Literally, the page has no data. There's nothing wrong with like how I'm picking out chunks. There's nothing wrong with the classifier. There's nothing wrong with any of that stuff. There's literally no data to parse. That's where it's wrong, but it takes a long time to figure that out if you don't have an easy way to like inspect the data to see where is this kind of like going wrong. So now what I do is I just literally, like at every stage, I just write tools, sort of like I'd write unit tests for the features to make sure the features get calculated correctly. Now I would write like kind of data inspection tools to like look at the data at each step of the pipeline. And so I guess to finish, this was, I guess, the biggest thing that I learned and was, I guess, a change in my thinking on working with machine learning versus more sort of traditional algorithms. Someone wrote this on Twitter, and it was one of those things that sounded quite trite until it kind of sunk in over time, and I started to think it's actually quite deep, which is that machine learning is about thinking statistically versus algorithmically. And so let's say for this problem, if you have 100 pages, 99 of them will have the data at the top, and one of them will have the data at the bottom for some inexplicable reason. If you write something that's correct for those 99 pages, most likely it's going to get that last page wrong. But of course, that's much better than getting one correct and 99 wrong, which I make if I make the opposite assumption, like the dates are usually at the bottom. And so, at least what I found is that for machine learning, it's often for problems where there's no option to get 100 of them right. That's just not possible. And so it's kind of, you're searching for what's right most of the time versus something that's algorithmically correct, where you would consider that wrong answer to be a bug versus what it is in this case, which is just kind of the cost of doing business. So thank you for listening to my talk. Thanks to these people for listening to earlier versions of it and helping improve it. And then if you want to talk to me now versus talk to me later, I don't really do QA, but you're welcome to come and talk to me in person with any questions or comments or anything that you want to talk about. I'll be here and I'll be at the conference. And then if you have data problems that you want to talk about later, here's my contact information. And thank you very much.